All right, welcome back. Okay, welcome back, everyone. We got 8.6, transforming sine and cosine functions, except for this time we're focusing on the shifting of the trig function to the left and to the right. Which brings us to your learning goal, horizontally shifting sine and cosine functions. You will see stretches in this lesson also, because that was from 8.5, but you will not see vertical, okay? All right, now let's focus on a new terminology here, phase shift, a horizontal shift of the periodic function. That is no different than any horizontal shift you've already done. We just call them phase shifts for trig functions, okay? Now you're going to see this written in two forms, the original form and the common form. This being the one that you'll be using, okay? Now, I've kind of written in some other variables because I want you to think about these transformations the same way, right? If these were for, let's say, a quadratic, you would have had the variables, a, h, and k, right? And your h told you the horizontal, your k told you the vertical, your a did the stretch. Same thing here, okay? Your c value in the original form tells you what your phase shift is, okay? And that same opposite applies. We see a minus c. So, if I did minus 2, that's really right 2. If I did plus 2, that's really left 2, okay? Now, the common form has a little bit of weirdness to it, right? If you look at it, all of a sudden, b, which helps us find what our period is, looks like it just moved and only distributed into theta, right? You can see that right here. The weirdness is that this did get distributed into both, but for whatever reason, we still just call that value c, but it is distributed in. So when you see something in the common form, which will be the form that you see it in, you have to divide b out in order to get what this was, right? Because if you multiply b in to get what c originally was, you would have to divide b out, okay? So you'll see things written like this. This b value still tell you what the period of the function is. And then your phase shift, you just take whatever c is, divide it by that b value, and that tells you what you're going to the right or to the left, okay? Now, I do have these graphs on the left. They're kind of left over, but just to give you, a little bit of a preview is we're going to go, if you have a sine function like this, we'll be moving it over like that or to the other direction, okay? Same thing with the cosine. Now, we're going to take a little break here. We're going to do a little Desmos exploration so you can just quickly see what this would look like. All right, so here we are in Desmos. We have a sine function graphed. If you look, there's also a cosine function, but I've disabled the graph, and you will see why, okay? And, this is just graphed as sine of x because you can see c is equal to 0. So if you watch what happens as I increase the value of c, you can see that even though it's a minus c, we are shifting, or phase shifting to the right, okay? And you can kind of see how it still ends up repeating, right? And if I go to the negative, I start moving to the left, all right? There's something interesting that happens when you shift these, right? If I go to 0 here, all right, we could see that our graph crosses. Come on, I get the 0. We can see our graph crosses the, 0, 0 point, right? Watch what happens, though, as I move this, right? Watch this. You get it right back to the same place. Look, crosses the 0, 0. And it looks the same as it did before. Okay, and think about that number 6.3. That's about what 2 pi equals, right? So, this phase shifting, the periodicness of sine functions does give us that repeating. And that's kind of why we tell you to graph over one period, because the rest is going to look the same. Now let's bring this back to 0. If I can get it there. Okay, and let me enable the cosine graph. And you can see that they're very, very similar. They just start at different points. Well, let's put a minus here. And, it would be, I wonder if it'll let me use minus c twice. No, because it's going to give c the same value. I'll just use minus d, although we will, think of that as the c variable, right? And you can see it automatically put it to 1, but let's put it back to 0. Watch what happens when I phase shift this to the right. Look at that. If I move it out 1.6, which is about half of pi, So pi over 2, just a phase shift of pi over 2, you know, I basically have the same function again, okay? So sine and cosine are very, very similar. And this is the weirdness when we start to work with both of these, is if when we shift them, and then we try to go, which function was that? Like if I just gave you one of these, I said, well, which one's the sine, which one's the cosine? You didn't have the graphs. It's kind of like, either, right? So there's a lot of overlap with sine and cosine. If you think back to the unit circle, there's a lot of overlap there in what their answers are, okay? So hopefully this kind of helps you understand it. Let's get back. Let's actually graph them. All right, so here we are. We have a function f of theta is equal to 2 sine theta minus pi, okay? Now, if you look at this one, it's hard to tell if this is the common or the original, right? If you think back to those functions that we just had, they had either b here for the original or b here for common. Well, we don't see a b value. We obviously can assume that a b value is 1, but we don't know if it's here or here. The good news is if b was here and we did our phase shift, right, it would be c divided by b. So whatever c is divided by 1, so it doesn't matter. So if you don't see a b, you don't have to worry about is it in the original or the common form, okay? Now before we graph that shift, I'm just going to graph it without the shift first, and then it's a little bit easier to move it over, okay? So I'm going to find our amplitude, which is 2, because that's what a is equal to, and then our period. So our b value is 1, so 2 pi divided by 1, so it's just 2 pi. So I go to my graph, I put 2 pi, I split it in half, and then, you know, I'm kind of abbreviating this because I know we did it in the last lesson, but remember we need 4 equal marks, and so sometimes it's easiest to just take the middle one and then take a half again, and then you can take this, add it to that to get to the third, okay? So that would be 3 pi over 4. We have an amplitude of 2, so I need to go up to 2 and negative 2, all right? And our original function, it's going to start here. It's going to go up to 2, cross through pi, down to negative 3 over 4. And of course, it would continue to go on, but we're only graphing these over a single period, okay? Now, we need to figure out what our phase shift is. Okay, phase shift. Now, back here, we said our phase shift was either what c is equal to, or it is c divided by b, okay? Now, because there is b value of 1, either of those is acceptable, so our c is pi. So our phase shift is pi, okay? Now, it's a minus pi, so we got to go to the right. It's always the opposite of what you would think for the horizontal, okay? So all of this needs to get shifted over by a pi amount, okay? Now, to do that with the pointer, right, this starting point here is now over at pi. This end point here is got to go over a single pi to 3 pi. So I need to add a little bit here. So I add another 1/4 pi. So that would be 5 pi over 4. Okay, and I'm going to add another one for 3 pi. Okay, and I'm going to shift everything over. So I'm starting here now. Let's do that in green actually. Starting here, going up, down, and back. And the green function is now the correct one shifted, okay? Now, did you have to graph it without the phase shift? No, but I find it to be a lot easier because then you can just look at what's already graphed and go, I just need to move all those points over this amount, okay? But again, you don't have to do it that way, okay? All right, now here's another one, a little bit trickier, right? We got a lot more going on here, all right? Let's just break it down without the phase shift, and then we focus on the phase shift, and it won't be too bad. So we have an amplitude of 3, because that's our a value, okay? Now we have a period, which is 2 pi divided by b, and if we look, we have a b value of 2, because remember, it doesn't have to be here anymore. It could be right in front of the x, or whatever the input variable is. So I have to go 2 pi divided by 2 for a phase or a period of pi. So I go to my graph here, right? And I'm going to have an amplitude 1, 2, 3, negative 1, negative 2, negative 3. And I need to go, I need 4 segments up to pi. And I'm actually going to graph this just a little bit. No, I'll do the whole distance, okay? So we got pi, we have pi half, we have pi. Did I do the last one right? Oh my goodness, y'all. Y'all are gonna rip me in that feedback. Okay. Let's adjust this. All right, there's the laugh. Okay, so here's the mistake. 2 pi, when I took half, was pi. That was correct, but a half again should not have been pi over 4. It should have been pi over 2. So this should have been pi over 2. This should have been 3 pi over 2, not 3 pi over 4. And the other one is solid, though. No, the other one's not solid. It should have been 5 pi over 2. Y'all thought you were going to get me this time. The clock ain't resetting. It's not resetting today. And I really feel like I'm actually just talking to myself. Okay, let's go back here, all right? Okay, so I got pi over 4 here, pi half, and then 3 pi over 4. That should be correct for this one. Okay, I graph my cosine. Now cosine, remember, it starts at the amplitude. So I'm starting up here. In fact, let's use the highlighter. So I go down and finish. Okay, now we calculate our phase shift. All right, and our phase shift is going to need to be C divided by B this time. Okay, now our C here is all of this. So it's pi divided by 2, okay? And then our B is 2. So this is pi divided by 2 divided by 2, which we know that could be 2 over 1. We know that we can flip this to be pi over 2 times 1 over 2. And so that really means pi over 4, okay? So let's recap here. Pi over 2 is our C value. Okay, we divide that by B. That ends up with a keep change flip, and we end up with pi over 4 as our phase shift. Now there is a plus here, so we are going to the left. We are not going to the right. So everything you see needs to shift over a pi over 4 amount. So I'm going to have a negative pi over 4 here because we are going to need that left side. Okay, so instead of starting at 0, I'm starting at negative pi over 4, and it should go down, reach, up, back. Notice how everything is a pi over 4, distance away from each other and all those areas that it would have crossed. Okay, so in this one, the red one is our final answer. Okay, all right, I got one more for you guys. Hopefully I can make it through, no mistakes. So we have an amplitude. This time it's -3. Okay. We have actually, I'm going to have you guys pause and try this. All right. Because I didn't really prepare any for you guys to do, but I think it's a good opportunity for you guys to try this one. It's not too different from the last one. Okay. So why don't you guys pause it, give this one a try, and then I'll go over it. Okay, so we have an amplitude of -3. We need to figure out what our period is. So that's 2 pi divided by B. Now our B value is here. It's 1 over 3. So we're going to have to go 2 pi divided by 1 over 3, which we just keep change flip that to be 2 pi times 3 over 1, or just 3. And so that means our period is 6 pi. Okay, so this goes, all the way out to 6 pi. All right, now we need to slice and dice this up into 4 pieces. So I'm just going to take 6 pi and divide it by 4 to get what each individual distance would be. And so that would be 3 pi over 2, right? So 3 pi over 2. And then you can also think of it as half of 6 pi for the middle. So that's just 3 pi. Okay. And then we're going to have, what, 5 pi over 2? Is that right? No. No. Yeah? No. No. Definitely not. Okay. So that would be 9 pi over 2. Because this is 1.5. I'm thinking of this without the pi, right? 1.5, 3, 9 divided by 2 is 4.5, 6, good. I got that distance of 1.5, pi between all of these, okay? So we have a sine function with an amplitude -3, so we are starting from the top. Oh my goodness, pluses here. We are going to start, here, but we're going down instead of up, okay? So I'm graphing this. We go down, cross, up, back, okay? Now, we need to do our calculate our phase shift. All right? And our phase shift is always going to be C divided by B. Well, our C value is just pi, okay? And our B value was 1/3. So again, you have a keep change flip situation. So it becomes pi times 3/1, or just 3. And so our phase shift becomes 3 pi. Okay. Now we have a plus here. So that means we are going to the left. So I need to extend our graph. Okay. And if you think about it, this distance here is 3 pi. And so I need to have a 3 pi here, or a -3 pi, and a -3 pi over 2. Okay. Now all of this is going to get shifted over to the left 3. We're going to do this in green. So we start here, we go down, up, and back. Okay, and you can see 3 pi to 6 pi, that's a distance of 3. -3 pi to 0, that's, for the starting, that's a distance of 3 pi. So we are good, okay? So this was pretty much just like last lesson, except for we added in that phase shift, okay? And, be careful with those pluses and minuses, and just remember C divided by B. If there's no B, it's 1, which means that the phase shift is just C, okay? All right, that's all I got for you guys today. Hope, I think I made it through without any errors. And I'll see you guys next time.